Hello everybody. So today I want to walk you through 10-4 perimeter and area in the coordinate plane. So in this one, there's nothing really new here. It's a little more complicated than before, perhaps, but we've done all of this before. So I'm just going to walk you through one of the problems to show you the different ways you could approach this type of thing. So let's take a look at number 13, which is one of the more complicated ones. So in number 13, we got 4 points, and we want to draw and classify the polygon with the given vertices, find the perimeter and area of the polygon. Okay, so I already drew it. You should always draw these. It'd be almost impossible to do if you did not do that. Okay, now we need to classify. Okay, remember classifying, you need to, this is a quadrilateral, right? So with quadrilaterals, you're needing to find slopes, you're going to need to find distances. Now this one's going to be fairly straightforward because it's nice and symmetric. So for example, let's say I want to find the slope of NP. So starting off with, let's find the slope of this side right here. Okay, so slope of M of NP. Let's see here. NP, rise over run, so it's going to be 10 minus 5 over, 5 minus 3. That is 5 over 2. Okay, and let's compare that really quick to the side that looks very similar to it on the opposite side. So if I look at LM here, well, what's my rise of this one? Well, it goes from 0 to 5. What's my run? It goes from 5 to 7. That's a 2. So what that means is that these two slopes are the same, which means these two sides are parallel with each other. So okay, so that's equal to L and M. Okay. Now let's do the slopes of the other sides, because we need to be sure. Eyeballing it can get you in trouble sometimes. So let's find PM. Oh, not PM. I want to do PL. Yes. PL. Okay. So what's happening here? Rise over run. So I'm going from 10 down to 5. So that's a negative 5 for rise. What's my run? From 5 to 7, that's a 2. Okay, negative 5 over 2. Interesting, okay? And let's compare that to the opposite side. Okay, we're going to see, well, what's happening here? Is going rise over run, goes from 5 down to 0, also a negative 5. And we're going from 3 to 5 to run a 2. Oh, wow, these two sides are also parallel. So that means that these two sides are parallel as well, so in M. So cool. So that means we're definitely dealing with a parallelogram of some sort. But we'll notice that these sides are not negative reciprocals of each other. They're negative, but they're not negative reciprocals. So that means we're not dealing with a rectangle here for sure. No, right? So no right angles here. It could be parallelogram, maybe a rhombus, but we need to check. Okay. So for us to check that, though, we need to take a look at our sides, find the distances of our sides. And again, this is pretty easy because it's nice and the orientation makes this very easy. Okay, so let's take a look at one of the sides. Let's look at NP. NP. Okay. So let's see here. NP, I'm going to 3 to 5 in terms of x. That's a 2 squared. Going from 5 to 10 in terms of y. Okay, square them up, square root of 29. And you notice that if you compare all the other sides, same deal. For example, P and L. If we look at P and L, Well, what's the difference in terms of x? It's 2, which is the same. Difference in terms of y, 5, same. So it has the same distance. Check this side. Difference in terms of x, 5 to 7 is 2, 0 to 5 is 5. Again, we got 2 and 5. Last side, what do we got? 3 and 5 for x, that's a distance of 2. 5 and 0, get a difference of 5. So all sides are the square root of 29. So cool. So what that means, all sides are the square root of 29. So what that means, if we got parallel sides and all the sides are congruent, the same length, but not right angles, this is a rhombus. Boop. Rhombus. Okay. So now we need to find perimeter and area. Okay. Perimeter is a piece of cake, right? Because we got the sides already. Okay. So perimeter, I'll just write it over here. Perimeter is add up the 4 sides. 4 square root of 29. Right? One side is 29. Got 4 of them. Area is a bit trickier. Now let me show you, there's a couple ways to do this. One is to do it kind of directly using the rhombus formula, which is honestly the easiest one. But let me show you the triangle method as well, because sometimes the problems won't be quite as easy of this one. Okay, so the trick of using this one, what's called the triangle method, is you kind of have to box out your quadrilateral. Okay, so boop, 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 boop. Boop, 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 boop. Okay, I'm boxing it out. So, and what the idea here is you want to get the area on the inside here, right, of the rhombus, which sometimes this can be tricky to do. Okay, in this case it's not, but sometimes it can be tricky. So what we're going to do, what you can do instead, is find the area of the rectangle. Rectangles are super easy to calculate. And subtract out the area of the triangles. Okay, so for example, what's the area of that rectangle? Area of rectangle. Well, let's see here. The length, we're going from 3 over to 7, that's a 4. What's the height? We're going from 0 up to 10. Okay, so the area of the rectangle is 40 square units. And we got 4 triangles here. Now, good news is all these triangles are going to have the same area. That's not always going to happen. It's just convenient in this case. Okay, so remember, 1/2 base times height. Let's look at one of the triangles. Point. So let's look at this triangle here. Okay, so this triangle, well, what's this length right here for the base? Going from 3 to 5. So it's going to be 1/2 times 2 times, what's the height? We're going from 0 up to 5. It's a 5. Which is, let's see, 5. Okay, but now we got 4 triangles. 4A triangles is equal to 4 times 5 is 20. And so the area of the rhombus is the area of the rectangle minus the area of the 4 triangles, or 40 minus 20, or 20. Okay, now the other way we can do this is, which is probably easier in this case, is directly use the formula. Okay, now rhombuses do have a formula. The area of a rhombus is 1/2 times P times Q, where P and Q are the 2 diagonals. Okay, so there's one diagonal right there. Oops, I'll do a different color. All right. case. Undo. Take those off. Okay, there's one diagonal right there. And there's the other diagonal right there. Okay, and those are pretty easy lengths to get in this case. So that's why this method is way easier. So let's see. This one diagonal right here, well, what's the length of this diagonal? We're going from 3 to 7, that's 4. That's 1/2 times 4. What's the other diagonal? Vertically here, well, we're going from 0 up to 10. All right, it's 10 times 10. And again, you get 20 square units there. Okay, so there you go. Either method will get you there. And that's the thing with these sets of problems. There's often more than one way to approach them. So it's kind of up to you to think about it and find the most efficient solution. Okay, so I'm going to stop right here. Please let me know if you have any questions, and I will talk to you later. Thanks, guys.